Okay, so we're going to go through these two examples. We'll do a couple of textbook problems, but this is the second day of exposure to related rates type of problems. Remember that related rates, dy dt, or dx dt, dz dt, whatever it is, it's all going to be in respect to time. Okay, so d something dt. Alright, so here we go. A man 6 feet tall walks at a rate of 5 feet per second toward a light pole 16 feet tall. At what rate is the tip of his shadow moving when he is 10 feet away from the base of the light? And at what rate is the length of his shadow moving when he is 10 feet from the base of the light? So let's highlight some stuff that we're looking for. First of all, these are rates, so they're going to be d something dt. And here is the tip of his shadow, and here is the length of his shadow. Two different things. So the diagram is huge, at least to get you started on this particular one. Some of you probably already noticed what the diagram will look like. Just drawing it just real quick. So there's the light. Okay. And here is man who's 6 feet tall. Now let's go ahead and label 16 feet, 6 feet. And it says whenever he's 10 feet away from the base. Okay? And he is walking toward the light. So I'll put like little lines showing that he's walking toward the left. Okay? Alright. So we want to know, first of all, let's go through our acronym. So DREADS, the diagram is done. Is there anything that I could possibly draw from the diagram? Say again? A shadow, yeah. So there are more pieces. Nice. I'm going to highlight this length of 10. But then I'm going to highlight, just as Tret said, his shadow. Okay, so this is the length of his shadow. Okay. So the way we're going to set this up, because I have two different lengths, I want you to look at this as from here to the man, let's label it X. And then from here to the end, we can label it any letter. I'm just going to label it Y. And you could put S if you want for shadow. Okay? And now what we're going to do is we're going to look at rates. What are the rates given or the rates that are unknown? Okay? So can anyone tell me a rate that we were given? Go ahead. Go ahead.
At a rate of 5 feet per second.
Okay. So 5 feet per second is something of a rate. And these rates are going to be these something dt. Okay? What letter should we put, since based off of our diagram, what letter would we put? D what dt is equal to 5 feet per second? X. We could put x, but if we do x, it can't be a positive 5, it has to be a what? Negative 5. So notice y. I want you to use x, but this has to be a negative 5. And the reason of it being is, it's not because it's moving to the left. Don't think physics based in that way. It's because the length of x is what? Decreasing. Okay? And there's that again. When the derivative is negative, the position is decreasing. Vice versa.
So if we use y, it would be positive.
Yes. If you put dy dt, it would be positive 5. In my opinion, that just creates weird work. I would suggest the x being the way you represent this velocity. Okay? dx dt. Alright, so what is the rate that we're looking for? D what? So dy dt is going to represent this length of his shadow. Okay, so the length of his shadow is dy dt. So we're looking for dy dt. So dy dt is equal to question mark when x is 10 feet. We're also looking for the tip of his shadow. So where his shadow ends depends on how far is he away from what? The light. So this is going to be a little bit weird. It's going to be dx plus y over dt. Okay? So dy dt is the length of his shadow, but the tip that the speed that the tip is moving at is dx plus y dt. Now, real quick, this is the same as if we were to look at this. So I want you to know right now that the derivative of x plus y in respect to t is the same as dx dt plus dy dt, independently. It almost feels like it's a distribution, if you will. Okay? And again, we want to know this when x is 10 feet away from the base of the light. Okay. The rates are good to go. Now we need to know what equation could we set this up as. What do y'all think? Pythagorean theorem could be a suggestion. The only thing that I'll say no to that is never were we asked to find z, nor were we given z. There it is. Similar triangles from geometry. Okay? So think of a proportion, if you will. We could say 6 is to y as 16 is to what? X plus y. Always put them in variable forms first, and then when we ask our questions, those two questions that we ask, then we'll see what can change to constants. But always variegate stuff with variables first. Yes?
Where did you get the 6 from?
The 6 is basically what I'm saying is the height over the base for this guy is proportional to this height over this entire base. Okay? So, similar triangles. Let's go now to, now that we know the equation, you can do it this way. Okay? You can leave it in this form, or you can simplify it. To me, if I leave it in this form, it's going to be a nightmare with doing quotient rule if I derive both sides. Okay? But if I always try to simplify before deriving, I can do what I did in geometry of cross multiplication. You get 16y on the other side, and then simplify all that together. Okay? So subtracting the 6, I'll get 10y is equal to 6x. You with me, guys? Okay. And if you wanted to simplify it even further, dividing both sides by 2, it's up to you. Because it's all proportional if you know what similar triangles are all about. Alright, I'm going to leave it at 6x is equal to 10y. And now I'm going to, let me make some room right here. I'm going to do the A part of dreads. I'm going to ask myself those two questions. Here we go. I'm looking at x first. Does x change throughout this problem? Yes or no? Yeah, it's decreasing. It's the distance between the person and the light pole. It's changing. Yes. Should I leave it as x? Yes or no?
Yes.
Yes, because how else, when we derive on the next step, how else are we going to get the dx dt piece that we need to use if we don't leave it as x variable? Okay? So let's move on to the right side. Is y changing throughout this problem? Yes, it's increasing. The shadow is, actually the shadow would be what? Y is representing the shadow, and as you get closer to the light, what's that shadow going to do? It's going to decrease. Okay? So it too is changing. Should I leave it as y, yes or no?
Yes.
Yes, because how else will I be able to put an answer that says dy dt when I differentiate the next step? Okay, so now we're ready to implicitly derive. So what's the derivative of the left side? Remember, we're looking at this right here. What's the derivative of the left?
6 dx of dt.
Yep, 6 dx dt, okay, is equal to what is on the right? 10 dy dt. Nice. Now, for part B, which I think is the easier one to find first, that length of the shadow, we know that length is represented by this, the dy dt. So all we're going to do is look for dy dt by plugging in what for my dx dt? Negative 5. So we have 6 times negative 5. So we have negative 30 divided by 10 would be anyone? Negative 3. So dy dt is equal to negative 3 feet per second. This is the answer to part B. Now listen to the way I'm going to say this, and you can go back and watch the video if you need to. This is the way you're going to write it out as like an equation based. If I asked you to write it out in a sentence, there's many different ways that you could do that. One way that you could say is y is changing at a rate of negative 3 feet per second. Or you can say y is decreasing at a positive 3 feet per second. Because that decreasing piece that I said in words already took care of that negative. But if you say on the test that it was decreasing at negative 3 feet per second, what you just said is that it was actually increasing. Don't do two double negatives to make that positive, okay? And last but not least, you could say that it's moving. Okay, moving is the same as speed is to velocity. Which one of those has direction? Speed or velocity? Velocity. The absolute value of velocity is what? Speed. So when I say if it's moving, that's the same as speed. So you'll say it's moving at a positive 3 feet per second. I'll say those again. Moving at a positive 3, decreasing at a positive 3, or changing at a negative 3. Questions?
Could you just do right or left instead?
I didn't hear it.
Could you say right or left instead?
No, don't say right or left, because this doesn't have to mean right or left. It could mean forward or backwards. It could mean up and down. So I want you to say it in that context. Okay. Now, if we're looking for part A's answer, which is this, we just found out that dy dt is negative 3. So I could put negative 3 right here. We already know that dx dt is a negative 5. So this dx plus y dt, anyone, would equal what? Negative 8. Negative 8 feet per second. So you can say the tip is moving at 8 feet per second. The tip of his shadow is changing at negative 8 feet per second. You with me? Or it is decreasing at a positive 8 feet per second. Again, that decreasing took care of that negative piece. Any questions before I go on to the next example? So in my opinion, this can be like a level 6 or level 7 if you struggle to set it up. But once you set it up and you got here, this is fairly easy. Fairly easy. But the hardest part in my opinion is knowing to set up these pieces independently and writing dx dt as a negative 5 instead of dy dt as a positive 5. Okay. Let's move on to our last example from the notes, and then we're going to do some problems from the textbook. So a trough. So if you've ever been to a farm and you see animals eating from a trough, imagine this is a trough and it is 10 feet long. Here we go. The diagram is huge on this. That's why I already have it drawn out. But 10 feet long is talking about the horizontal distance. I don't know why why it's not. There it goes. So this 10 feet long is there. And then it goes on to say it's 6 feet across the top. And then it has an altitude of 4. Okay? And yes, the 6 feet is the same over here. If water is being pumped into the trough at 9 cubic feet per second, how fast is the water level rising when the water is 2 feet deep? So let's imagine that the water is 2 feet deep. Okay? So there's the water. Give it a little bit of kind of dimension, if you will. Alright. And let me make sure that you can see that. 4 feet for the height. So diagram is pretty much done. Okay? So now let's move on to the rates. What rates are given?
dV over dt
Yep.
equals 9 b cubed per second.
Perfect. dV over dt equals 9 cubic feet per second. Let me ask you, is it positive or negative? Positive. How do you know? It's pumping into. See, in all these subtle things, you're going to have to ask yourself, because then you're going to miss it by a negative. Okay? Alright, what rates are we looking for? The height. How fast is the height changing? So if you were to just stare at it and you see the height just growing and getting higher and getting higher, how fast is it moving? Okay? So we're going to put dH dt is equal to what? And you could have done A for altitude. I'm just going to use H since we've been using H for other things. Is equal to what? When what? H equals 2. Okay? Okay, so rates are done. Let's go to our equation. What am I using? The volume of a triangular prism. So the volume is big BH, and big B is the area of one of these bases, which we said to be triangles, right? So what's the equation of a triangle? 1/2 base times height, that's big B, and then we're going to multiply it with this other height, and I put that in blue for a specific reason. Because here we have two different heights. We have one that is in red that is representing this height of the triangle. And then we have this one over here in blue that is representing this height. So if you wanted to use A for the red one, right here, instead of height, you want to put A for altitude, that's fine. But we're not going to have to do that in this specific problem. Who can tell me why? Close. I think you're right on it. Here we go. When we get to this equation, which now I'm going to check off, the next thing is to ask ourselves those two questions. Here we go. If I go through this, you tell me, is V changing throughout this problem?
Yes.
Yeah. Should I leave it as V? The answer is yes.
Yeah.
Because how else am I going to get dV dt when I derive the next step? Okay? If I change it to a different letter, I can never get dV dt. Okay? Alright, this base of the triangle, is it changing throughout the problem? Let me say it one more time. Of the water. Is the base of the water, which is right here, is that base, because that's what we're analyzing. We're analyzing the volume of that water. You're right, in respect to the tank, it doesn't change. We're going to use that here in just a bit. But the water, it does change. Okay? Should we leave it as B, do you think? No, we're going to talk about that here in just a bit. Now the red H, is the red H the height of the water changing throughout this problem? Yes. Should we leave it as H? Yes, because that's what we're looking for right here. Okay? And now, the other H, the one in blue, is it changing throughout the problem? No. So guess what we can do right now? We can plug in 10 right now. This is why I want you to ask yourself these questions. I've told you it's all you need to derive first, and then plug in the number. The only exception to that is the question that I just asked. Because H doesn't change throughout this problem. This specific one, it's always going to be 10, even with the water. You plug that in before deriving. Okay? Alright. So let's change B. Okay? And B is representing, again, this 6. We're going to change it to a different variable. You with me? Okay. So I could say B is to H as what is to what? 6 is to 4. 6 is to 4. So look, this base over height, let me highlight it in green because I have a lot of highlights. Base over height, which is right here, is the same as 6 over 4. Now when I asked y'all earlier, was the base changing when it was 6? And you said, no, you were right about the tank. That didn't change. But the water is. That's why I'm using the tank's original dimensions for those similar triangles or for that ratio proportion. So base over height is going to be a ratio of 6 over 4 all the time regardless. Okay? Because this tank isn't transforming throughout the problem. It's just staying constant forever. Okay? So base over height is proportional to 6 over 4. Now I'm going to solve for B. And I get 6h over 4, which reduces to 3h over 2. This now is going to be substituted in where B was over here. Because I want everything written in terms of H. Because that's what we're going to be working with. Okay? So here we go. Let's simplify this equation. We have V is equal to 1/2 times that B substitution times that height times that 10. All I did was plug in the substitution for this right here. Any questions before I simplify? So this will become 30h squared over 4. 30 because I have 3 times 10.
Oh, okay.
So everything multiplied, all the numerators, if you will, and you can interpret these as over ones. So multiply all your numerators together, all your denominators together.
Well, then you can simplify that.
Yeah, I simplified it.
Yeah, so 15 over 2, my bad. So yeah, V is equal to 15h squared over 2. Cool. Now, that everything is written in terms of just the variables that we'll be working with, and it's simplified, I can go to derive. What's the derivative of the left side? dv dt. What's the derivative? Well, first of all, let's move 15 halves over to the door. Constant multiple rule. What's the derivative of h squared? 2h dh dt. Okay. And then we're going to multiply that 15 halves back in, which some of you already see. Those two cancel. And you're just left with 15h dh dt. All that's multiplied is equal to dv dt. Do we have h? Yep. What is it? 2? Which is that last part. Substitute and solve. So I'm going to substitute h is 2 right down here. And then I also have dv dt. of 9 is going to be right here. So that we have 9 is equal to 30 times dH over dt. So 9 over 30, what does that reduce? 3/10. So you'll say dH dt is equal to 3/10. Notice that I do not do the diagonal. Please don't do that. Just do that for units. What are my units of measure on this? Feet per second. You guys are stronger, faster. Alright. Is this positive or negative? Positive, because it is filling up. So you could say, here we go. This is increasing at 3/10 feet per second. Okay? You can say it's changing at a positive 3 feet per second, or it's moving at a positive 3 feet per second. Or, you know what I mean, 3 over 10 on all of those numbers. 3/10 feet per second. If you want to round it to 3 decimal places, that's fine too. Questions? Okay. So now we're going to practice.